So when we look at these vocabulary words right here, we have talked about all of those before, right? So, but instead of us talking about them specifically in the context of one type of function, we're going to talk about them in a general way and be able to identify them from any graph that we look at, okay? We also don't need our computers today, so let's go ahead and close them, okay? So when we look at the domain is what? The domain is what? It's our x values, okay? That is the set of all inputs or our x values, okay? Inputs is just meaning it's what we're inputting into the function. Okay, whereas range is the set of all what? Y values, so it would be our outputs, which is our y values. And when we look at domain, we look from left to right. When we look at range, we go from where? Bottom to top. All right, so we can have maximums and minimums on our graph. What does it mean to be a maximum? It's the highest point. Yep. So that is the largest or the greatest output. So it's our greatest y value. It's our highest point on the graph. Okay. The minimum, it would be the least y value or the lowest y value, okay, of the function. Think of a maximum. That's a max. It's a high point. And a minimum is a low point, okay? Now, we also talked about axis of symmetry, specifically in the context of quadratics. But are quadratics the only thing that's symmetric? No, you can be symmetric. Like, other things are symmetric too, okay? And an axis of symmetry is the imaginary line that divides the graph into two equal parts. Now, is every single graph ever symmetric? No. So will we always have an axis of symmetry? No. Okay. X-intercept is where the graph crosses the x-axis. Okay. When we have an axis, or when we have an x-intercept, those are the points. It's the point x, 0, where the y value is 0. That's what makes it an x-intercept. Okay. Our y-intercept is where the graph crosses the y-axis, which is the point 0, y, because our x value has to be 0. Now, we are also going to look at increasing and decreasing intervals, okay? So when we look at increasing and decreasing intervals, we are looking at our graph from left to right. So if I am looking at the graph from left to right, am I looking at x values or y values? X values. So we are going for our x values from left to right when we look at increasing and decreasing intervals. So moving from left to right, a function may increase, decrease, or remain constant for certain intervals of x. So we're going to look at this graph and we're going to talk about it. So what I'm going to do is I'm going to start at the leftmost part of this graph, okay? And I'm just going to follow this graph. What am I doing? Am I increasing, decreasing, or remaining constant? Increasing. When our graph goes up, it is increasing, okay? So if I look at this, where does that arrow on the left side point to? Negative infinity. Okay, so it goes from negative infinity to, at what point does it stop increasing? What x value does it stop increasing? -2. So from negative infinity to -2, our graph is going up. It's increasing. Okay, now, What is happening after that? Is it increasing, decreasing, or remaining constant? Constant. It's not going up or down. It's staying the same, right? So where does that section start being constant at? What x value? -2. When does that section stop being constant? +4. And we use parentheses when we're dealing with these, okay? We always use parentheses when we're dealing with this, and we'll talk about that in just a second. So now, decreasing. What is happening from here down? It's going down, right? Where does that section start? What x value? 4. And where does this arrow going on the right side? Positive infinity. Because it's on the right side, so it is positive infinity. If it's on the left side, it's negative infinity. Okay? So that is where that graph is going, increasing, decreasing, or remaining the same. Okay? I want to talk about why all of these right here get parentheses. Okay? So does domain and range always have parentheses? No. Right? Because whenever we're talking about a graph, we can do this just right here. If I have an open circle point on my graph, okay? We talked about this way back at the beginning of the year, right? If we had an open circle on our graph, does that mean it can be equal to a point? No, right? If it's open, we can't equal it. That is when we just had less than or greater than. Okay, that was when we had our open circles, right? When it is just less or greater than. And with open circles, we always use parentheses. We also always use parentheses when we're dealing with what? Infinity. Whether it's positive infinity or negative infinity. Y'all remember our silly little cat that we had at the beginning of the year? All right. Now, we can also have closed circles. If I have a closed circle, can it equal that point? Yes. Okay? That is when we had less than or equal to or greater than or equal to. When we had a closed circle, we used a point or not a point. We used a parentheses or a bracket. Bracket. Okay? Now, here's another thing to remember. If we have a straight line, okay, a straight line is made up of a bunch of points that are all touching along that line, right? So if I have a straight line, any point, would that right there be an open circle or a closed circle? Closed. If it does not have a visible open circle, it is like we know it's closed, okay? So that can just be any little line. Okay? So that is what we do for domain and range. We use those rules, okay? And we're going to typically use interval notation instead of inequality notation. Just because it's a little bit easier to write interval notation, you write it more like you read it. Whereas with inequality notation, it's a little bit different, but they are interchangeable. So if I had negative infinity to 4, written like that, I could rewrite that as a domain with inequality notation. Is x less than or equal to 4 in that scenario? Or is it less than or greater than 4? It's negative infinity to 4. Is that less than 4 or greater than 4? Less than 4. And it's a bracket, so it's less than or equal to. We can use those interchangeably, okay? You can use either one of those. We are typically going to use our interval notation. It's just a little bit easier to write. You write it just like you read it from the graph. You don't have to do any extra pieces with it like you do with inequality notation. But that is how we do domain and range, okay? The reason for increasing and decreasing intervals that we always use parentheses, regardless of open circles, closed circles, arrows, not arrows, we always use parentheses in there. for a very specific reason. So we're going to, real quick, have a conversation. So if we are watching, or if we're in a car and we say our speed is increasing, what does that mean is happening? What is happening to our speed? It's going up. We're getting faster, so it's like, right? Right? If we're in the car and the speed is decreasing, what's happening? We're slowing down, right? It's like, right? Okay? But I want us to think about something. If we're watching Fast and Furious, right? And it shows a clip of their speedometer, right? And we have to get up to go make some popcorn. And we pause the movie right as the speedometer says 100 miles per hour. Okay? Do you know if they're increasing or decreasing? No. Because in order to know if something's increasing or decreasing, you have to be able to compare it to the things on both sides of it. You have to know what's happening before it and after it. So, like, we can't be, but if at that singular point, can we tell if it's going up or down? No. So that is why it always uses parentheses, because at a singular point, like you would have at 4, we can't tell if it's going up, going down, staying the same, because without anything to compare it to, we don't know, right? So we always use parentheses, right, when we're dealing with that. Does that kind of make sense? Just a little bit? So with increasing and decreasing intervals, we always use parentheses. The only place we're really going to put brackets is in our domain and range, okay? Because domain and range is like our hard, fast limits of what we can and can't go past. Whereas increasing and decreasing is just like, is the graph going up here? Is it going down here? What's happening here, okay? So I want us to go ahead and we're going to do some examples where we go through all of our key features. But before we do that, I want us to actually look at this section right here, and we're going to write out how I expect our answers to be for all of these. So we have very clear expectations of how we write what, okay? So when we start with domain, okay, for domain, it is always our x values, and they go from left to right every single time. It can use parentheses, it can use brackets, you can use inequality notation, does not matter. But we're always looking from left to right with our x values. For range, we are looking at our y values from bottom to top. Again, you can use parentheses, brackets, depends on what's happening there. Axis of symmetry. If we have an axis of symmetry, we will write it as x equals wherever it's symmetric, whatever that number is. Okay? But for axis of symmetry, for like this graph here, is that graph symmetric? No. So do we have an axis of symmetry? No. So the answer to that here would just be none. There isn't one. NA. Okay? When we're talking about key features, not every graph is going to have every type of key feature. None is an answer. Okay? What you can't do, though, is leave it blank. Okay? Leaving it blank isn't the same as saying none, because leaving the blank is just like more like I don't know what I'm doing. Okay? But write in there that there isn't one. Okay? Now, when we're dealing with x-intercepts and y-intercepts, your answer should be written in a point. Okay? So when we write a point, we have x, comma, y in parentheses. That's how we write it every time. So that's how our answer should be with these. Okay? For our x-intercept, it'll be x, comma, 0. For our y-intercept, it'll be 0, comma, y. But we will have a point in there. Then for increasing, decreasing, and constant, it will be your x values. And it's going to be from the left to the right in parentheses every time. Okay? That is how we do that. So we're going to go ahead and we're going to actually find all these things from this graph that we have here. So when we look at this graph to this right here, and I look at the domain, where is the leftmost part of this graph? -2. It starts right here, right? Will that be in parentheses or a bracket? Why? Because it's an open circle. Okay? Then, as it goes to the right, where does that arrow right there tell us it goes? Infinity. Parentheses or bracket? Parentheses. Infinity always gets parentheses. Okay, now, for range, we're looking bottom to top. Where's the lowest this graph goes? 0. That's our lowest y value. Parentheses or bracket? Parentheses. Then, where's the highest this graph goes? Infinity. Parentheses or bracket? Parentheses. Now, we already said this graph isn't symmetric. Okay? Does it have an x-intercept? Yeah, it touches the x-axis. But let's talk about where it touches the x-axis. Right there is an open circle. Does it equal an open circle? Does it actually touch the graph where there's an open circle? No. So do we really have an x-intercept right there? No, because it's an open circle, right? It's not actually there. So that right there would be none. So, because what's happening there, okay, we're going to pretend here, this line of blocks across the floor is our x-axis. This right here, where I put that yellow paper, that is where the hole is at. Or I'll do this. That right there is where that open circle's at. If I am bebopping across this graph, we're in Minecraft world now, okay? And we're bebopping. That right there is an open hole that goes straight to lava. Rough road. Okay, I'm just bebopping. What happens if I step right where that hole is at? I'm going to fall into the lava and die. It's going to be very unfortunate for me, okay? Because it doesn't matter how many times I fall into lava. Every time I fall into lava in Minecraft, I panic. And I lose all sense of sanity. And I die. It's a problem. My husband makes fun of me.
What about the toilet?
Not everybody's that way.
Okay? But, so, that open circle, can anything be there for that open circle's at? No. Because it's like an open hole full of lava, right? So, is there an x-intercept right there? No. Because, does the graph actually touch the x-axis? No. It's lava, or you would step and fall and die, unfortunately. All right. Now, is there a y-intercept, though? Yes. Where is the y-intercept? Not 0, 1, but it's 0, 0, 2. It is the point 0, 2. Because it goes up right there. That is the point. And that is the point 0, 2. Because all we do is write in the x and y coordinates.
My eyes are getting the best of me.
Now, we're going to look at this graph from left to right. As we go from left to right, is it increasing, decreasing, or staying constant? Increasing. Where does it start increasing? What x value? -2. When does it stop increasing? Never. It goes to infinity. So, and we always use parentheses here. Okay? So it's from -2 to infinity. Does this graph ever decrease?
No.
Is this graph ever constant? So that's how if it's not decreasing, you put none. If it's not constant, you put none. If it's not increasing, put none. So we're going to do a few more of these. All right. Now, let's go ahead and look at the next graph. Okay, we are still looking for our domain as our x values from left to right. So what is the leftmost part of this graph? -2. Parentheses or bracket? Bracket. Why is that a bracket? Because it is a closed circle right there. So it goes from -2 to, what's the rightmost point? Parentheses or bracket? Because again, we have a closed circle. Okay, so now we're going to look at our range. Our range is our y values from the bottom of the graph to the top. So where's the lowest y value at? Parentheses or bracket? Bracket. Because even though that's a line right there and we don't see an individual point, it is understood that there's points all over that line, right? The only time that we know it's an open circle is if we visibly see an open circle, okay? If we don't visibly see the open circle, it's not an open circle, it's closed. Okay, now, if -2 is the lowest, what's the highest y value? 0. And that again is a bracket because we have our closed points. Now, is this graph symmetric? Yes. Okay, so we're going to do x equals, at what x value could I take and fold that graph in half at? 0. So it is x equals 0 is our axis of symmetry. Now, x-intercepts. Where? We have 2 of them. Yeah. Where is our first x-intercept? So how would I write that as a point? -2, comma.
Oh, is it a U?
0. And it's not a u because we're just writing points. And then the second x-intercept is where? 2, comma 0. And then where is our y-intercept at? So how do I write that as a point? 0, comma -2. All right. That is us just listing out where these points are located. Now we're going to look at increasing, decreasing, constant. When we do this, remember, we are looking at our x values, and we're going from left to right with parentheses. So I'm going to start on the left of this graph. Am I increasing, decreasing, or constant? Decreasing. Okay. Where does that section start decreasing? What x value? -2. Where does that section stop decreasing? What x value? 0. So it's from -2 to 0. Then after we decrease, what's happening on the other side of that graph? It's increasing. It's going up. What is that interval? 0 to 2. And is that graph ever constant? So we put all right, now we are good to look at the next example. So for this one here, let's start domain. What's the leftmost part of this graph? 0. And so that's our leftmost part. Is that going to be a parentheses or a bracket? Parentheses. Why is it a parentheses? Because it is an open circle. All right. The rightmost part of this graph is an arrow. So what does that mean it's going to? Infinity. So it's 0 to infinity. Now range. We're going from the bottom of the graph to the top. So we're looking at y's. Where's the lowest y value this graph has? It's at the bottom, so it's -infinity. Okay. Where is the highest y value this goes to? 3. And would 3 be a parentheses or a bracket? It's a bracket, because if there's not a visible open circle, we assume it is a closed circle. Yep. All right. Now, is this graph symmetric? No. So our axis of symmetry is none. NA doesn't have one. Now, if I would have changed this graph and made it instead look like that, would that have been symmetric? Yes. Yeah. Because it could have folded up over that line right there. But is that what our graph looks like? No. So it is not symmetric. Nothing we can do about it. All right. What about x-intercepts? How many times does that graph touch the x-axis? 2. But is this open circle really touching it? No. So what is our x-intercept? 2, 0. Now, does this graph have a y-intercept? I mean, but is it actually touching the y-axis? No. So we can put none, NA, absolutely not, no way, Jose. Yeah. As long as you're saying it does not touch, you're good. Okay? I just need you to make it clear you know that. Now, let's start at the left of this graph and go to the right and see what we're doing. Increasing, decreasing, constant. So when we start at the left, is it increasing or decreasing or constant? Increasing. So what is the x value where that starts? 0. What is the x value where that ends? So we look at our x values. So the x value right there is 1. Okay? The reason we have to use our x values for that is because if I was to say the y value is what we use, and we look at the y value of 1, how many times does the y value of 1 appear? Twice. Y's can repeat. Our x's won't repeat, so that's why we use x. X is a more exact location, whereas the y values can repeat. Okay? So that is what's increasing from 0 to 1. Okay, after we increase, what happens after that? It's decreasing. Okay, it's going down. Where does that section start decreasing at? What x value? When does that section stop decreasing? Infinity, because it's on the right side. So from 1 to infinity. Is that graph ever constant? No. No. Because are we looking at x values or y values? Since we're looking at x and it's on the right, it goes to positive infinity. If we were looking at y's and it goes down, that is negative infinity. But we're not looking at y's. All right. I want y'all to go ahead and I want y'all to try to do this one right here for me. Yes, ma'am.
Can I go to the bathroom?
Yes, go ahead.
It's not that I don't like it. It's that I don't like
What you looking for? In the drawer labeled glue sticks. I'm going to have to relabel that. All right. What is our domain for this graph? 0 to 4. Okay, when we have at 0, is it going to be parentheses or a bracket? Bracket. And then at 4, it's a parentheses. So we have bracket 0, comma 4 parentheses. Now, what is our range? 0 to 2. Okay. At 0, is it a parentheses or a bracket? What is that?
Bracket.
Bracket. And then at 2, it's a, there we go.
Parenthesis. There's no axis.
Is this graph symmetric? No, it is none. Yeah, there is not one. All right. For our x-intercept, where does this graph touch the x-axis? 0, 0. Where does this graph touch the y-axis? 0, 0. Okay. Where is this graph increasing? 0 to 4. Both with parentheses. Where is this graph decreasing? Never. So none. Where is this graph constant? None. All right. What I want y'all to do is I want y'all to work on those last few questions, and we're going to go over those tomorrow. Okay? And that is our lesson for today.